I am Mr. Tarrou. In this video, we're going to prove the triangle midsegment theorem. Now, we just did a video on that, and we did quite a few examples using this theorem, but we didn't prove it. So I'm going to take a little video here and do that for us. Now, the midsegment theorem says that a segment that connects the midpoints of two sides of a triangle is going to be equal to half of the length of the third side and be parallel. And for this proof, we're not going to do the typical two-column proof that you've been seeing me do now for hopefully, or at least hope watching me doing a lot of videos, that you've seen me do over the last number of videos. No, we're going to do it more in an algebraic type setting or analytical proof, where we're going to use our formulas for midpoint, distance, and slope to prove this midsegment theorem. Now, what I've done for convenience of simplifying the algebra is I've placed my triangle in quadrant 1, and again, we're going to do an analytical or more of an algebraic proof of this theorem. So to keep my algebra as simple as possible, I've put my triangle in quadrant 1. Now, this is going to represent any triangle. I'm just putting it in quadrant 1 so that all my coordinates say positive and it simplifies my algebra. I've also, since I can put this triangle anywhere on the XY axis that I feel is convenient, I'm going to put one of the vertices on the origin. I'm going to have the base of this triangle be any length, and I'm going to allow it to be any length by identifying the x-coordinate as a. So I don't know what the value of a is, so a could be 1, 2, 3, or 100 units away from the origin. Thus, the length of the side is unknown. And because I've ran it horizontally along the x-axis, that again is going to simplify some of our algebra for us. The third point, if I drop this third point down, I can make this an obtuse triangle. If I allow this point to come up very, very high, that'd be an acute triangle. I could even make this be an isosceles or a right triangle if I allow this point to move. And what's going to allow this point up here, this last point of our triangle, to move freely pretty much anywhere, or not pretty much, but absolutely anywhere, as long as I actually form a triangle, so I can't land it back within the same line, is I've got the values of B and C. Now, B and C can take on any values that is going to allow this triangle to be a triangle. I couldn't let this point fall right back here on this dot here, because then it would just be a line segment, or be anywhere along this, the x-axis, because then I wouldn't have a triangle anymore, I would just have a segment. But barring that, with an unknown value of B, unrelated to 0, 0, or A, and with an unknown value of C, the x and y values both being unrelated to these points and both being unknown is going to allow us to move this point anywhere we like, and we could be talking about an acute triangle, an obtuse triangle, or even a right triangle, or isosceles triangle, or any triangle for that matter. So I've got our midpoints marked, and I know I want them to be midpoints because I've got my tick marks here on my segments saying that these two segments are going to be congruent and these two segments are going to be congruent. Well, if they're going to be congruent, then I need to make sure that I do find the midpoint between 0, 0 and BC, and let's do that now. For the midpoint, you take x of 1 plus x of 2 and divide it by 2. You're basically finding the average of the x-coordinates. Y sub 1 plus y sub 2, and add those and divide by 2, so you're finding the average of the two different y values. So let's let this be x sub 1, y sub 1, and let this be x sub 2, y sub 2, and find that midpoint. So let's call this, let's see, how about, well, I'll leave it unlabeled, we'll just find the coordinate. So this midpoint here, that's bothering me, let's say midpoint 1, there we go. So midpoint 1 is going to be equal to let's see here, I'm going to take x of 1 and x of 2 and add them, and divide that by 2. I'm going to do the same thing with the y values, 0 plus c, and divide that by 2, just a second. I was rattling. And our midpoint over here on the left-hand side is going to be, well, what's left? 0 plus b is just going to be b, so we have b over 2, and 0 plus c is c, and that divided by 2. Alright, so this is going to be our midpoint for the left side of our triangle, so let's take this out and replace it with our midpoint of b over 2 and c over 2. Now let's find the midpoint on the right-hand side. What is the midpoint between these two x-coordinates and y-coordinates, or the midpoint of these 2 points here? Well, again, we're going to add the x's and divide by 2, so a plus b. And let's call that m sub 2. So a plus b divided by 2. Let's take the y values and do the same. Add those and divide by 2. And we get a plus b over 2 over c over 2. And I'm going to place this midpoint right here on the right-hand side of our triangle. And we will, on the next step of our proof, we're going to look at making sure that these lines are parallel. We're going to find the slope between a sub o and 0, 0. We're going to find the slope between these two midpoints, but first let me get this board cleared off for us. We got our midpoints, and we're going to find the slope. We're going to make sure that this midsegment and this third side are going to be parallel. Now, hopefully, since I've ran this segment along the x-axis and we have a horizontal line, we know that because, for one reason, the y-coordinates of our 2 points are going to be the same here, and the y-coordinates of our 2 points here are equal. And in a horizontal line, it's only the x value that's changing and not the y. But just for practice, let's run through those slope formulas. For our mid-segment, and let's color code this so I can tell what I'm doing here. Hopefully that purple shows up. We're going to find the mid-segment of, or the slope of the mid-segment. So the slope, let's see here, slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I want to subtract my y's over my x's, and I just need to make sure I keep it in the same order both times. So I think what I'll do is I'll go from right to left. We'll call this x sub 2 and y sub 2, and that'll be x sub 1 and y sub 1. So we have c minus 2, or c over 2, excuse me, minus, that's y sub 2 minus y sub 1, which is another c over 2, over x sub 2, which is going to be a plus b, minus x sub 1, which is going to be b over 2. Now, if you're not comfortable with fractions, this is probably quite scary, but we do need to eventually get comfortable with these. They keep coming up over and over and over again. I mean, if you use a ruler, you're doing fractions. Up the top, we have c over 2 minus c over 2. Now, all you need to subtract fractions is a common denominator, and we already have that. They have a common denominator of 2, so all I have to do is subtract the numerators, and that's not too big of a deal because c minus c, or anything minus itself, is going to be 0. So we have 0 over 2 divided by, well, let's see, I've got a plus b over 2, and I have b over 2. Well, our two fractions, again, have a common denominator, so all I have to do is subtract the numerators. And looks like I just have to add or subtract or combine like terms. So I have an a sitting here with nothing else to be combined with, so I have a, and I have a positive b and a minus b, so b minus b is 0, so it's just a over a by itself, and we just get a over 2. Well, 0 over anything is going to be 0. So 0 divided by 2, 0 divided by 20, 0 divided by 100, 0 divided by x. 0 over anything is going to come out to be 0. And normally when I have something over a fraction or a fraction over a fraction, I have to talk about how that we would take this bottom and flip it up and change the division to multiplication, because you don't really divide fractions. If you have two fractions, you multiply by the reciprocal of the second fraction. Well, that always comes out of the denominator, or the bottom half of our fraction. But I don't need to worry about doing that, because again, I have 0 over something, and 0 divided by anything is going to be 0. Okay, so I've just validated what I kind of already knew in the first place, which was my mid-segment is a horizontal line with a slope of 0, because my y-coordinates are the same. And we're going to do the same thing with the bottom line, and we're going to get that slope of 0 again, but just to make sure, let's see, again, slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So our slope is going to be, again, 0 minus 0 over a minus 0. We have 0 minus 0 is 0, a minus 0 is a, and oh, look at there, I got an answer of 0 again. So since my slopes are the same, my mid-segment and my third side are parallel. Well, time to clear off the board again, and let's make sure that the distances, that this midsegment is actually half of this third side, or that the third side is twice as long as the midsegment. All right, let's find the distance of this midsegment. Okay, now it's going to be a lot of fractions again, but they're all going to have common denominators, so it won't be quite as bad. Just relax, keep going on, and don't be afraid of those fractions. They're never going away. So this distance here is equal to what? Well, distance formula says that I'm supposed to take x sub 2 minus x sub 1 and square it, and add that with y sub 2 minus y sub 1 and square it. And all of these formulas, you know, I can say add the x's, divide by 2, add the y's and divide by 2, or for slope, subtract the y's and over the x's. The subscripts are all in here just to make sure that you do that subtraction the same in all of these, or addition, in all of these pieces. So not a bad idea to identify what you want to be as point 1 and point 2 and have those labels and make sure that you're doing your subtraction or your addition. It's more important with the subtraction, but making sure you're doing that in the same order in all the parts of these formulas. Otherwise it can throw off your answer sometimes. So the distance. Alright, so our midsegment, that length is going to be equal to the square roots of, let's see here, x sub 2, so a plus b over 2, minus x sub 1, so minus b over 2, squared, plus y sub 2, which is going to be c over 2, minus y sub 1, which is again c over 2, and distance formulas, and I'll see, well, we're in geometry, so maybe in Algebra 1 never quite looked that bad, but a lot of stuff's going to cancel right away. Like anything minus itself is going to be 0. So this over here is going to be 0. And what's happening here? Well, we're subtracting two terms with common denominators. So again, I don't need to worry about subtracting those or adding them. It's going to be over 2. And we have a plus b minus b. Well, again, kind of like we had in the previous screen, b minus b is equal to 0. So they just cancel out, leaving us with a. And our big square root. Okay, so 0 squared is 0. So this is going to cancel away, because when you add by 0, well, let's see, 5 plus 0, that's still 5. 10 plus 0, that's still 10. Okay, so when you add by 0, nothing changes, so there's no reason to continue writing that. And we have the square root of a over 2 squared. Now, what does a square root and a power of 2 do? Well, let's see here. 3 squared is 9, and the square root of 9 is, right back down to 3. 4 squared is 16, and the square root of 16 is, right back down to 4. 5 squared is 25. The square root of 25 is back to 5. So, if you only have one item or term inside of a square root, the square root and the power of 2, they're going to cancel each other out, leaving you with just a over 2. So our midsegment has a length of a over 2. Now I need to get this cleaned up so I have room for my last part of my proof, but I'm going to leave that information up there about that our midsegment has a length of a over 2. If we can prove that the length of this third side is equal to a, well then I've proven that the midsegment is half of the length. And, well, you know what? You just saw me work out a distance formula. Do I really need to work it out again? Can you find the slope of a line that moves horizontally by simply just counting out the points? Well, yeah, you can. I go from 0, 0 to 0a. Again, the y-coordinates are staying the same. So really, the length of the line, since the y is staying exactly equal, the same thing would happen if you were going vertically, but the length of that line, I already know the length of that line is going to be equal to a, because I'm going from 0 to a. So my third side equals a. Well, my midsegment is half of my third side. So I was going to stop and write out the distance formula again, but I can just count from 0 to a and know that that length is a. And again, my midsegment a over 2, that's half of my third side. We showed that the slope of my midsegment and the slope of my third side were both equal to 0, and those equal slopes meant those lines were parallel, and that means I'm done with the proof. The midsegment theorem says that the midsegment is equal to half of the third side, and it's parallel, and I'm Mr. True. Bam! Go do your homework.